We're returning to the Virginia coastline with a completely different perspective on one of the biggest civil engineering projects ever attempted in the United States. At first glance, the beaches look peaceful, but this stretch of coast is now seeing the fastest rate of sea level rise anywhere along the Atlantic seaboard. And right beneath those calm waters, a 10-million-pound monster of a machine is chewing through the ocean floor 24 hours a day. What appears serene from the surface is actually the stage for one of the most ambitious construction efforts in American history. Twin undersea tunnels, two brand-new man-made islands, the replacement of 27 bridges, and the relocation of millions of tons of sand and sediment. This isn't just another highway upgrade. As massive volumes of material are pulled from Virginia's rivers and bays, people are starting to ask, what else might be hiding in that sediment? And could this construction-grade sand be worth far more than anyone is admitting? Going under instead of over, building a taller bridge, simply wasn't feasible. But Americans have never been the type to back down from the impossible. So if they couldn't go over the water, they went straight through it. In 1957, more than a decade before the first moon landing, the U.S. opened the Hampton Roads Bridge Tunnel, the world's first roadway that let drivers plunge beneath the sea and resurface on the other side. Picture this. You're cruising along, then your car drops into a pair of tunnels nearly 100 feet below the waves. Sunlight disappears. For a few eerie minutes, you're surrounded by total darkness under millions of tons of water. Then, suddenly, you shoot back into daylight as you climb onto a man-made island that links the underwater tubes to a long bridge stretching to the opposite shore. Those original artificial islands each covered more than 15 acres and were built by dumping millions of tons of rock and sand delivered by barge after barge. Down below, crews worked in crushing pressure to sink enormous precast concrete sections, each one weighing thousands of tons with millimeter precision. When it opened, the Hampton Roads Bridge Tunnel was hailed as an engineering marvel on par with the Eiffel Tower or the pyramids. On opening day in 1957, roughly 6,000 vehicles used it. By 2008, daily traffic had ballooned to over 100,000, 16 times the original design capacity. After half a century, the same crippling congestion had returned, proving that even the greatest triumphs eventually need a second act. A challenge decades in the making. By the early 1990s, Virginia's government had had enough. They handed the Department of Transportation, VDOT, an almost impossible task: double the capacity of a vital corridor that runs both above and below the water, without ever fully closing one of the busiest routes in the region. This wasn't just an engineering puzzle, it was a financial and logistical marathon that would take decades of planning and $3.86 billion to crack. Studies dragged on for more than 20 years while the state hunted for funding. Traffic finally reached breaking point, worsened by two terrifying incidents. A 2009 storm that trapped drivers in flooded tunnels for hours, and a 2016 fire that forced dozens of people to crawl through choking smoke because there were no safe walkways between the old tubes. Those events lit a fire under the project. The new design added emergency escape passages every 1,000 feet, state-of-the-art ventilation, and fire suppression systems that meet the toughest modern standards. In 2016, Virginia committed to building two brand-new two-lane tunnels running parallel to the existing pair. 4 years later, the state signed a historic contract with Hampton Roads Connector Partners, a global supergroup made up of Flatiron, USA, Dragados, Spain, Vinci, France, and Doden Campen Bernard, Norway. Their mission? Widen more than 60 miles of I-64, replace 27 bridges, and construct two entirely new artificial islands in open water. Total price tag, $3.86 billion, enough to build 10 Wembley stadiums or power a mid-sized city with solar panels for half a century. More than 3,000 workers now operate around the clock to make it reality. Roughly 92% of the money comes from the Hampton Roads Transportation Accountability Commission, with the rest covered by state and federal contributions. The new tunnels are engineered to survive once-in-a-century floods, cast from salt-resistant concrete, designed to last 120-plus years. The same specifications used in Seattle's SR-99 tunnel and Boston's Big Dig. Meet Mary, the mechanical beast. To pull off this multi-billion-dollar vision, America needed a true titan of industry. Say hello to Mary, a 450-foot-long, 4-story-tall, 10-million-pound tunnel-boring machine named after Mary Jackson, NASA's first black female engineer who once worked right here in Hampton. Built in Germany by Herrenknecht, widely considered the Rolls-Royce of TBM manufacturers, Mary's 46-foot cutter head can exert 27 million foot-pounds of torque and generates 56,000 kilowatts of power, almost 40 times the output of a modern freight locomotive. Building and transporting her cost $70 million, roughly the price of 2 super yachts. It took 14 months to manufacture her in Germany, 4 months to ship her across the Atlantic, 4 more to reassemble, and 6 months of testing before she ever turned a blade. In 2023, Mary finally roared to life and began gnawing through the soft silt beneath Hampton Roads. The ground here is notoriously unstable. One small misalignment and the whole tunnel could collapse like a house of cards. To prevent disaster, Mary continuously pumps pressurized bentonite slurry to hold the surrounding soil in place while she advances. Behind her, crews immediately install 20-inch thick concrete segments that lock together to form unbreakable rings. To spin her 5 million-pound cutter head under the seabed, engineers used cutting-edge nitrogen-filled sliding pads, a technology never before deployed in an American subsea tunnel. After more than a year of non-stop digging, on April 17, 2024, Mary punched through the final wall of Earth. The control room exploded in tears and applause. Project manager Janet Hedrick called it the most emotional moment of her career. But Mary's job wasn't finished. She still had to be carefully disassembled underground, rotated 180 degrees, and relaunched to bore the second tube, a 6-month operation where the slightest mistake could have let the ocean crush everything like an empty soda can. By 2025, Mary was boring again, sharper and more precise than ever, inching forward a few feet each day while crews pump the excavated slurry to the surface for processing and place new concrete rings behind her. When everything is finished in 2027, Hampton Roads will boast 4 parallel tunnels offering 8 lanes total, the 2 1957 tubes converted to one-way traffic each, and the 2 gleaming new tubes handling the opposite directions. The entire system will swallow roughly 150,000 vehicles a day without breaking a sweat. Virginia's quiet sand empire. Drive through Virginia's coastal plain and you'll see more than just cranes and beaches. Beneath the surface lies a largely invisible industry that fuels much of the state's growth: sand and gravel extraction. Every year, Virginia mines about 11 million tons of sand and gravel worth close to $180 million, mostly from open pits. But a growing number of observers have started wondering what happens to the millions of tons of material dredged from riverbeds and floodplains during maintenance and infrastructure projects? And is every single ton really accounted for? The Virginia Department of Energy oversees mining with strict permits, yet the chain of custody for dredged material, once it leaves the water and enters processing, isn't always documented in exhaustive public detail. It's a small gap, but gaps breed questions. The new artificial islands. 2 enormous man-made islands are rising from the water to serve as the portals for the new tunnels. The North Island, near Hampton, is expanding daily with control buildings, ventilation shafts, and elevated ramps that will feed cars into the tubes below. It has already swallowed 1.6 million cubic yards of fill, the equivalent of roughly 480 Olympic swimming pools. The South Island, and originally built in 1957, has now doubled in size and functions as the project's nerve center, home to Mary's launch pit, giant electrical substations, concrete plants, and living quarters for more than 200 workers. At night, it glows like a floating city under floodlights, with cranes swinging 24/7. Every load of dredged material brought in for these islands is supposedly tested, treated, and approved. Standard procedure, say officials. Yet the sheer scale and sophistication of the processing have caught the attention of geologists and independent researchers who wonder whether these operations might also be gathering valuable data or valuable minerals along the way. The official story. According to state and federal agencies, everything is perfectly above board. Large-scale dredging in Virginia's waterways is described as routine environmental upkeep and navigation channel maintenance. The U.S. Army Corps of Engineers removes sediment from the James, Rappahannock, and York Rivers every year to keep shipping lanes open for the Port of Virginia, one of the busiest on the East Coast. Environmental impact statements are filed, mitigation measures are taken, and excess material is reused for beach replenishment or construction. In short, take sediment from where there's too much, put it where it's needed. A tidy, self-sustaining loop. Yet one detail remains stubbornly opaque. There is no single, continuously updated public database showing exactly where every cubic yard of processed, dredged material ultimately ends up. That lack of end-to-end transparency doesn't prove anything nefarious, but it does leave room for curiosity. And curiosity has a way of uncovering things. Is there more than sand in that sand? To most people, the millions of tons coming out of Virginia's rivers look like ordinary construction fill. But a handful of geologists and investigative reporters have begun asking whether some of it might be considerably more valuable. Over the last 10 years, low-key surveys have found that certain stretches of Virginia's river systems carry trace amounts of heavy minerals, including monazite, a known host for rare earth elements. Rare earth metals such as neodymium, praseodymium, and dysprosium are absolutely critical for permanent magnets in electric vehicle motors, wind turbines, smartphones, and advanced defense systems. Right now, China controls roughly 85–90% of global refined supply, so any potential domestic source, no matter how small, is of intense strategic interest. Researchers from Virginia Tech and independent mineralogists have pointed out that the geochemical signature of some local river sediments matches areas known to host economic deposits of monazite and xenotime. One geologist, speaking off the record, described certain samples as anomalously enriched, subtle language in academia, but explosive in the mining world. Local journalists have quietly reported that not all dredged material stays in Virginia. Some loads, after initial processing, are trucked or barged to specialized facilities out of state, officially for further quality testing or beneficiation. Where it goes after that, and what exactly is extracted, remains shielded behind commercial confidentiality. The bigger picture, sand is the second most consumed natural resource on Earth after water. We use more than 50 billion tons every year, and demand is skyrocketing. But not all sand is equal. Desert grains are too round, so the construction industry depends on sharp, angular river and marine sand. That insatiable need has turned riverbeds into strategic assets, and sometimes into battlegrounds. At the same time, certain heavy mineral sands naturally concentrate rare earth elements, titanium, zirconium, and high-purity silica used in semiconductors and solar panels. As the world races to break China's stranglehold on these critical materials, every potential new deposit, even marginal ones, gets a very close look. Whether Virginia's dredged sediments contain commercially viable concentrations remains an open question. Extraction costs, environmental restrictions, and grade all have to line up perfectly. but the combination of massive state-sponsored dredging, limited end-to-end material tracking, and documented heavy mineral presence has been enough to spark persistent low-level speculation. Environmental trade-offs. Large-scale dredging always affects ecosystems. Riverbed mining can disrupt fish spawning grounds, alter water flow, and change sediment budgets for entire coastlines. In Virginia, every permitted project requires an environmental impact statement, yet long-term, site-specific monitoring data is not always easy to find in public archives. That scarcity of granular follow-up data makes it harder to judge the true ecological cost over decades. No smoking gun, but plenty of smoke. For years, a loose network of academics, former contractors, and local watchdog groups has shared the same three observations. Virginia's coastal plain is known to host heavy mineral sands with trace rare earths and strategic metals. Several of the companies involved in the dredging contracts also have divisions that serve the defense and high-tech sectors. There is no comprehensive, up-to-date public ledger tracing every ton of processed material to its final destination. Taken together, those points don't prove secret rare earth mining is happening today. But they do explain why the theory simply won't die. Meanwhile, the science keeps moving forward in plain sight. USGS reports openly confirm that Virginia's coastal sediments contain economically interesting levels of ilmenite, magnetite, zircon, and high-purity silica. Those minerals already have established markets in steel, pigments, ceramics, and electronics. Whether any portion of the current dredging program quietly evaluates material for even higher value fractions is something only a handful of people truly know. Thanks for watching. We'll see you in the next one, wherever the next hidden story is waiting to be told.